Hello. Welcome back to another episode of Voxel Heist, my Unity tutorial series where hopefully by the end we'll have a fully fledged game. This episode, titled Unity's Input System, will be going through what I call the new Unity input system, although I believe it's been out for a couple of years now. But first we'll be going over my task from the last episode, where we had an order of numbers appear in a random sequence, but consistently in this sequence. So, if I open the player controller, you can see that we have quite a few debugs, and with it loaded up, you can see that at awake we had debug 5, start we had debug 2, update debug 4, fixed update debug 3, late update debug 1. So this was the order of events. Hopefully you got it down pat. So for this episode I'm going to remove all of this, save, and just head back over to Unity. So looking at Unity's built-in input system. When we start a new project in Unity, you'll see that we have this item here. This is the input system actions. So I can double click on it and it'll open a new window, and you can see it's already populated with the basic, or the, I guess, sort of standard movement that you expect to see in games. What's nice is it's also populated with gamepads, so that could be an Xbox controller, WASD, so that'd be your keyboard, a joystick, so if it is on like a plain rig or something like that, along with XR controllers, so I believe that is also virtual reality. You can also see that we have things set up for attacking, interaction, crouching, jumping, etc., along with UI inputs as well. So what we can see from this screen is that we have, for example, if we look at move, we can see how it uses either W, A, S, and D, or the arrow keys. You can see that the movements, because up, down, left, and right is a 2D axis, it can only work on a plane, there isn't a third dimension. You can see that is a 2D vector, which is a vector 2. If you remember from last episode, we had a look at vector 3s, which are basically data types that can hold and store 3 floats. 2D vector, or a vector 2, holds 2 floats. And with that explained, we'll be looking at how to actually interact with the inputs within our code. So if I close this, I won't save because we didn't really make any changes, and open our player controller script, we can start by adding another using at the top. I believe I explained this many episodes ago now, but using allows us to get a library which has code within it. It makes it easier on our end to interact with different things, but Unity has its own different sub-libraries. So I'm going to be using Unity Engine again, but I'm going to do a dot and have input system, which will allow us to use the built-in input system. I'm going to start by creating a private vector2, and this will be our movement direction. DIR, short for direction. Then going to go into update and have movement direction. It won't equal our transform.position, but it will be from a public input action reference. Call this move. And this will be reading the vector 2 from the Unity input system. So you can see that we're searching for something called move. It'll be action, and then it will be reading a vector 2 from that action. If I head over to our Unity project, you can see that we have an input action reference. It's populated by the existing input system. These are all the different actions. And we can place in move. If I save that, then head back over to our script. I'll create a fixed update because we're going to intend to use this with our rigid body, and fixed updates are where physics calculations should be done. And I'm just going to do our debug.log in here. So we're saying our movement direction, and then we're passing in the movement direction. So in theory, if I press play, you can see that depending on which key is currently being pressed, we'll get different inputs and outputs. So we know that that's working now. So to apply our input to the rigid body, first we'll need a reference to the rigid body. I'll just call this RB. And we'll also want a movement speed. I'll just set that to 5. Then in fixed update, in order to actually affect our character, we'll need to access the linear velocity of the character. We'll create a new vector 3. This is going to contain our move direction x. So remember, this is a vector 2, so it only has an x and y. But we're going to be transferring that to a vector 3 like this. So movement direction, and we do a dot to get the sort of subcomponents. So we can grab the x, do 0, and movement direction dot y. And we can times this by our move speed. So heading back over to Unity, you can see that our player controller is asking for a rigid body, and we can go ahead and just add one to our script and drag it onto our player controller. So if I save and press play, you can see that with WASD I can move our character around. However, they are slowly sinking through the floor because they currently have gravity on them. But we've also set their velocity to 0, which is kind of counteracting it, which is why it is having a very gradual descent. We can avoid this by adding a box collider onto our player model, and I'll do a capsule collider actually. We can set it up so it's roughly covering our character, and we should no longer sink through the floor. So, another thing with rigid bodies and colliders. Because our character is a capsule, so you can see that there's only this one point touching the floor, we need to have some constraints. So this will be freezing the rotation of the character in X and Z, because we don't want them flipping forward or cartwheeling, but we would like them to rotate on the y-axis when we want them to. But other than that, hopefully that's all okay. Yeah, and there we go. So you can see that we now have movement of our character using physics based on the rigid body and the inputs that we give. I'm now going to clean up our script a bit, because I know that the rigid body component is going to be on our actual game object. I can just do private rigid body RB and have that as a get component, because again we can use get component in reference to the game object to just apply it. And as we're doing it in awake, it will do it before any of the other code executes which relies on it. I'll also get rid of our debug.log. We're also able to have our character look in the direction that they're moving. We'll be in fixed update. We'll do if movement direction doesn't equal vector 2.0. So again, the exclamation mark here is saying the opposite of what this is. So this line will only run if movement direction does not equal 0. So if we are moving our character, we'll go into Quaternions, which I won't go into too much detail on, but Quaternions are used in calculations involving 3D rotations. From what I remember from university, it was how rotations can cancel out and you're not actually able to move, if I remember correctly. But anyway, it's just a function that we'll be using to convert our movement to rotation. So in this line, we're getting a quaternion, which is essentially a vector 4 to rotation. And we're creating a look rotation, which is a function within quaternion. And it creates a rotation with a specific forward and upward direction. So our forward is our movement direction, and our up direction is vector3.up. Then we can just do transform.rotation equals quaternion.rotate towards, we'll do transform. Our current rotation, the to rotation that we want to rotate toward. Yeah, I'll make another public float, pressing Control D to duplicate the line, and have this as rotation speed, and I'll have that set as 5 as well. Rotation speed. And we'll times this by time.fixed delta time to just keep it in line so it's not as jittery with our frame rate. And just testing, this is going to be quite slow, so we'll do 500 because time.fixed delta time is a very small number, so we need to bump it up quite a bit. So if I press play on our scene, you can see I'm starting to think one of these axes isn't correct, you know? Okay, let's go back into our code and see where we've messed up. So in order to debug this, I'm going to, funny enough, do a debug.log and do transform.rotation along with our to rotation. So I can press play. So after a bit of scrolling through forums, as I couldn't remember the exact input, because we are converting our movement direction to a vector 3D, we couldn't use the movement direction, we had to use the linear velocity. So I've put that in its place. Rigidbody.linear velocity, I've done .normalized, and as this converts it to a unit vector, so it will always have a length of 1 whilst preserving its actual direction. Doing this means that the player won't be able to move quicker in a diagonal direction, because if you think about it, if they have +1 in this direction, +1 in this direction, that's then not +1 in the diagonal, it will be the combination of both of those, so they're additive. So hopefully now, fingers crossed, if we go ahead and press play, you can see that our player does face in the direction that we're after. And you can see that I can hold down the diagonals and they're not going off at any faster speed. Whee! Yes, that's something I do need to work on. The current linear velocity and gravity. So what we can do is just, okay, I'm actually going to rework this line quickly. We'll do vector 2 temp move equals movement direction dot normalized, given the vector 2. So we can get rid of that. We'll then have this times by move speed there. And we can plonk temp move into move direction. Then we can have the linear velocity dot y. So this will keep gravity affecting it like normal. Hopefully. I haven't tested this, so I'm curious to see if it works correctly. Hopefully everything still works fine. Yeah, it appears to. And we have our normal gravity as well. Excellent. So we're preserving that. As beforehand, we were timesing this entire thing by our movement speed, which would have increased our linear velocity by our movement speed if we kept that there. And we can normalize our movement direction outside of the actual vector 3 here. So I can get rid of our debug.log, and I think that's clean enough for our basic movement. But anywho, thank you for watching. This, I feel, has been a hectic episode, as quite a few of my notes haven't panned out as much help as I thought they would have. But in the next episode, we'll be looking at giving us a more detailed player movement, see if we can smooth some things out, and set up a fully implemented player controller script. I'm not going to say that there's a task for this episode, just given that with how, okay, that's actually a bit nicer, with how this episode was, I'm not sure there's much in terms of task to do besides just following along and trying to understand the code. So we'll set that to 800F. I'll put that as a private float because I'm happy with the rotation. Tempted to do the same for the movement speed. Yeah, we'll do that as well. Okay, I'm going to actually, I think I have an idea of the task. Back in a second. Okay, I have set a challenge. This episode's challenge is, and I'll go into this in a bit more detail to give you guys some clues, but when the player walks around, I've now set it up so that if I press left shift, they can sprint, so they move twice as fast. You can see me alternating between pressing left sprint and taking my finger off of it. So, clues for this, you can see that we have added a new input action reference called sprint. This is the existing sprint. Sprint is a button type, which is based on a boolean, so it would be either true or false. Is the button being pressed? Yes or no? I've got a snippet here showing the sort of usage of this, but again, I'm not showing the full thing. So see if you're able to implement the sprint button, which again is bound to left shift on a standard keyboard, and yeah, see if you're able to set the player's speed to a number higher than the current movement, and when sprint is not being pressed, set it back to the original move speed. Hopefully that's an alright challenge. But anywho, thanks for watching. Appreciate you being here. Feel free to like and subscribe and join the Discord down below. Next episode we'll be looking at embellishing our player controller, adding different things that we intend to have down the line, maybe like interactions and crouching. And yeah, we'll just see where the next episode takes us. Hopefully I'll have more of a plan for that one. But like I said, I'll see you next time. Bye.